Hello everyone. Welcome to this training session on statistical data analysis using SPSS. My name is Vamsidhar. As a part of this session, I would be looking at the two-factor ANOVA model. In our earlier session, we have looked at one-factor ANOVA or one-way ANOVA, where the major intention was compare the means of multiple groups of data. The grouping can be done either on a categorical variable or a scale variable using a cutoff point. But we were doing analysis of or comparison of the means across the various groups. But if the same analysis I do it not on one factor, not on one variable, if the grouping is done not on one variable but on two variables together, that is where we are calling it as a two-factor ANOVA model. And the two-factor ANOVA model in SPSS comes under a group of models called general linear models. GLM univariate models is what is the typical name that goes for the two-way analysis of variance procedure. It comes under the group of general linear models, wherein it models a dependent scale variable based on its relationship to categorical and the scale predictors. So basically, whatever we would like to do the mean comparison of, we take that as a dependent scale variable, and we said in case of two-way analysis of variance, we require at least or we require two categorical independent variables. So as a part of our independent variables, we even call as two different terms. One are called as factors, the others are called as covariates. Factors are nothing but categorical variables which are used for predicting the dependent variable, whereas covariates are scale predictors. So as far as two-factor ANOVA is concerned, I am more bothered about the two independent variables to be the categorical variables itself. But when I am considering, let's say, a couple of scale variables also along with categorical variables, then we would be looking at analysis of covariance and few other aspects which we'll cover as a part of our next sessions. But in this current session, when we are talking about two-factor analysis of variance procedure, our intention is straightforward. The two-factor analysis of variance, the two factors whatever we are considering for a grouping purpose, they are only categorical variables itself. And the major important thing in two-factor ANOVA or any general linear model mechanisms is we also look at the interaction between those two independent variables which we are considering. Right? Probably if I say I want to find out, I want to compare the means, right? I'll look at the case question, probably that would become more easier for you. I want to compare the uniformity or equality of the means of the cholesterol levels based on gender and smoking status. Means probably when I have done one way ANOVA, one factor ANOVA, we were comparing the cholesterol, the average cholesterol levels across different genders. Is A1 equal to A2, or A average cholesterol of males is equal to average cholesterol of females? Or I was looking at average cholesterol of non-smoker equal to average cholesterol of occasional smoker equal to average cholesterol of heavy smoker. These are like two different tests if I am considering two two separate one-way ANOVA analysis. But when I am considering it as a two-factor ANOVA, I am even looking at the kind of interaction that is existing between the gender and the smoking status. It may so happen that a male heavy smoker may have a completely different average compared to a female heavy smoker, or a male heavy smoker has the highest average whereas female non-smoker has the highest average. Some different kinds of things could come out when I am taking the combination of the two independent variables. That is what we call as the interaction effect. And even our one way and two way ANOVA procedure helps us even in comparing the means across the two independent variables. Also, the two independent variables will be factor variables itself, no covariates will be here. But I would apart from looking at their impact in isolation, the two factor ANOVA analysis procedure also looks at the impact on the cholesterol by the combination of both the gender as well as the smoking status. That is one of the major important thing that has to be considered. So some of the assumptions that this model goes with is the errors are independent of each other, and the error is typically normally distributed. Some of the assumptions, just from a understanding standpoint, if I want, it is more like the errors are normally distributed. Now, this is very much important in case of two-way analysis of variance procedure. The dependent variable has to be a scale variable, whereas when we are talking about the factors, we generally use two words: fixed factors versus random factors. And as we have discussed, factor is nothing but categorical variable. In some cases, what could happen, that categorical variable will have a fixed set of values. For example, gender, male, female, it cannot be anything else. Or here also, in case of smoking status, okay, we are saying never smoked, occasional smoked, heavy smoke. Whereas there may not be anything else which is omitted, but probably they, in this case, they are called as fixed factors. But probably if you look at, let's say, states in a country, or probably you look at states in a country, S1, S2, S3, or stores in a city, S1, S2, S3. Probably if the fourth store is added, it may go as S4 and it will have a different quantification to it. In this case, the store should have to be treated as random factors, whereas when we are considering males or smoking status, we call them as fixed factors. So as a part of our two-way analysis of variance procedure, I am more looking at two categorical variables as the fixed factor and one scale variable as the dependent factor. This is what typically goes as a part of two-factor analysis of variance. So as a part of the exercise now, we will try to check this aspect. Check for